Thank you. It's so great to be here. So my name is Srđan, and I'm an iOS developer at Shape. That's us. At Shape, we are always looking for something cool and interesting to work on. And the best way to get such projects is to always be on the frontiers of technology. So I'd like to start this talk by showing you an example of a project that we recently built for Space 10, IKEA's innovation lab. The project is called Spaces on Wheels, and it challenges the traditional idea of the car and explores what will become with a car once they gain self-driving autonomous capabilities. Will cars stay just cars, or could they become something more than that? So they researched that, and they came up with some pretty cool concepts like hotel room on wheels. Imagine exploring the new city without even getting up from your bed. Or healthcare services on wheels. Blood checks, GP, anything comes to you. Or this one that we'll probably see first, a grocery store on wheels. Forgot to buy some salad for the dinner, 2 taps of a button, the store is in front of your house. So they researched this, they explored the options, but they wanted to present it to people, and how to do that? Obviously, the best solution would be to build them, but it would be too expensive and the technology is not yet there. So they reached out to a 3D studio to build these things out of vertices and textures. And guys did an amazing job, as you can see. And what was left is to put them in the real world for people to experience them. So that's where Shape comes into picture, and together with Space 10, we built an AR app. Let me show you how it works like. So when you open the app, you'll see this list of spaces, as they call them. There are more than 3. They have many of these spaces. Choose the one you like, choose the one you need, and then you can book it. It works like ordering a taxi or ordering an Uber. So you have on the map, you have all nearby spaces, and then you choose your destination, where you want the space to arrive, choose the time, and then confirm the booking. Nearest space will be rerouted to your position, and after a while, you should get there. Now, there is no actual space coming. So instead, we pop up this AR experience screen, where you can experience this space in augmented reality. So all that user needs to do is place a marker where the space should arrive, and hopefully it arrives there. Now this is all being simulated on the device. There is no API or anything. It's just like a showcase of how these things would look like if we had them, hopefully in some years. All right, there it is. This is our grocery store. So you can go over there, pick up some veggies, and make that salad. If Space 10 came to us 2 years ago or even less, we could not build this because the technology was not there, at least not available to so many people around the world. So what changed? Well, Apple introduced ARKit. But before we get into ARKit, let's do a really short review of how we got there. What was the problem that Apple actually solved with ARKit? So if you think about augmented reality and what it is, it's basically making people see things that don't really exist in the real world. How do you do that? I guess the ultimate solution would be to hack into people's brains, connect to their neural pathways, modify some signals, and have them experience things. But we are not yet there, so we have to take one step back and think about how we experience the world, mostly through our eyes. So light bounces off the world around you, falls on your retinas, which send signals to your brains, which create images in our consciousness. So we cannot hack brains, but we can hack this visual field through which we see. To do that, we are, of course, using a device. It's not a perfect solution, far from it, but it's a glimpse in what's coming, and a window into a totally new world. Now, we've had our phones with cameras for a decade or more. So why is this happening only now? Well, there was a problem. And that's the problem of how do you project the virtual content on top of the real one so that it actually appears part of the real world. And to do that, you need to know how your device is moving and rotating with respect to the world around it. That was the problem that was very hard to solve. And some very smart people have been trying to crack it for years. They came up with a number of solutions and techniques, and the one that proved to provide best results is called Visual-Inertial Odometry. It's a bit fancy name, but it's actually quite self-explanatory. It's a combination of visual data from camera with inertial data from accelerometer and gyroscope. So camera captures frames, and then with computer vision algorithms, the system finds some features, points of interest, tracks those across frames, combines that with accelerometer and gyroscope data into like a stream of position and orientation estimation. Sounds quite easy from this high level of point of view, but if you get into details, it's this. And if we want to learn more, it keeps going, and it just keeps going. Now, if you like math, linear algebra, calculus, this is super nice to read. But if all you want to do is make AR apps, you don't have to know any of this, because Apple, of course, implemented it in ARKit. And this tracking, pose estimation, that's the main feature of ARKit, and that's actually what enabled Apple to provide us with these tools to create augmented reality experiences, or ARKit. Now, this is not the only feature. There are a few other features that are quite interesting and very helpful to make realistic augmented reality experiences. For example, ARKit can detect planes, like horizontal and vertical surfaces in the scene, like floors, walls, desks. So you know where exactly you can position objects. For example, if you have a sofa, you want it lying on the floor, not floating in the air, and this feature helps you to do that. Internally, ARKit builds a sparse 3D reconstruction of the world. So, although you cannot actually scan 3D objects, you can do heat testing on the device. So, for any point of the screen, if you would project a ray onto the real world, the system, the framework, can tell you where exactly would it hit. It's an approximation, but it's good enough so you can correctly place your objects so they don't overlap with the real world. Now, knowing the structure of the environment helps you position things and place them properly. But in order for this stuff to look realistic, it has to also be lit properly. So you have to know something about lights in the scene. And ARKit is doing light estimation by estimating light intensity and the light color temperature. And it gives you that information so you can adjust your lighting of your virtual stuff to match those. Even more, since ARKit 2, which came out this September, it's also automatically generating environmental texture. It's like a 360 map of the world around you that's used for reflections. Most of the materials in the 3D scene are actually reflective up to a certain degree. So this helps a lot with realism. It really boosts the realism of these AR apps. There is so much more. As you've seen in the previous talk, it can detect images, and you can start AR experiences from those images. It can do the same from objects. You can give it a scan of a 3D model, and it will find it in the scene, and then you can start experience from there. You can share the scene understanding with another device or more devices, so you can create multiplayer experiences, so people experience the same augmented reality. And there is more, a bunch of other small features. The one question is, how does ARKit render the virtual content? And the answer is, it does not. ARKit is not a rendering library. It's not a 3D engine. ARKit solves the problem of tracking and scene understanding, but for rendering, it actually encourages you to use other proven and capable frameworks to do the rendering. Unity and Unreal were supported since the beginning, as well as Apple's own SceneKit. Now, SceneKit is Apple's framework for 3D rendering. It's very simple, but very powerful. Not as powerful as these two beasts, but more than enough to create some great experiences. All right, so I think I've talked enough for today, so let me actually make something useful. So I'd like to show you how easy it is to create these AR apps on with ARKit. So my idea was to have to create a small game and to create it from scratch. So really from scratch. So I'll open Xcode and create a new Xcode project. When you're creating Xcode projects, you're always starting from a template, and there is augmented reality template. So we choose that, and name it something. You can keep everything as is. This template has some stuff pre-configured, and it does something, but we don't really care because we want to start from scratch. So I'm going to delete almost everything, and I'm going to delete the assets it comes with. So all that we are left with is this view controller, which is basically like a view, full screen view that the user will see. And this view is of ARSCN view, which is basically a type that's coming from ARKit, which renders this augmented reality experience. If I were to run this, it would be just black screen. So let's actually try to display something. ARKit is a session-based API. What it means, it's doing the tracking and processing estimation while there is a session running. So first thing you need to do is start an AR session. To do that, so when our view appears, this is a callback this function that will get called. When the view appears, we create a configuration that describes what kind of session we have. In this case, we are using world tracking configuration. There are a few others. For example, if you want to track user's face with front camera, or usually we use this one. Now, let me try running this and see what happens. Let's hope this will work. All right, looks like it's actually working. That's good. Yes, you need to give camera permissions because it's an AR app. And that's what you get. It's like an AR view that's just displaying the camera feed. So nothing fun for now. Let's try to add something to our virtual reality, augmented reality. Sorry. I prepared some assets for our game. I'm just going to drag them, if it will go, into our project. Here I have a scene with two 3D models. Somebody might recognize the one on the left. And let's try to display this scene in the AR. So all you have to do is load the scene into this scene object. You give it file name, and then you have to set the scene on the view. Let's try this. here they are. So everything is working, tracking is working all right. They stay fixed in the position relative to the real world. Can go closer. So yeah, it's that simple to get something in AR. So it's really that simple, a few lines of code. Let's try to make a game now. My idea was to have something like Space Invaders, but I came up with something quite similar. So we'll have these pickles in like a grid, and then we'll fire these cats as a missiles. So cats and pickles, yeah. Let's first create a grid of these pickles. But before that, I'll just hide these two models. So for each object or node in the scene, I'll set its hidden property to true. Now, create pickle. What this does is takes this pickle object and creates a copy of that. Unhides it, unhides the object, and returns it. Now, with a pickle, I can create a grid or a swarm of these pickles. It's a rather longer function, but it's very simple. I create an empty node that will contain the grid. Then I iterate in like a grid fashion over float numbers. And for each point in a grid, create a pickle, set its position, x and y, to the point in the grid, and add it to the swarm. Add whole swarm to the scene, and position it. Now, the way AR Session's coordinate system is configured is when you start, it will look into -z axis. So if you put something at -3z, it will actually be 3 meters in front of the device. And y is up or down, ½ meter up. I want my cats to actually collide with these pickles. And SceneKit can do physics simulation. In order to make nodes or objects participate in the physics simulation, you have to assign physics bodies to them. So I will just assign simple sphere physics body and set its contact test bit mask to 1, which will make it participate in the physics simulation. Let's see what we have so far. So, oops, that was not all right. The reason is because by default there is gravity enabled. So you have to disable the gravity, but we'll do that in a minute. Let's start with our cat as a missile. Let's do that first. So first, I'll have this function that creates a cat. It's similar with as the function that creates a pickle. Takes the cat, makes a copy, unhides it, and we also set physics body immediately. So with that cat, when I tap the screen, I want my cat to be launched into the pickle swarm. So, what was that? Fire. Yeah. So I override this method touches begin when I tap the screen. Now I get few errors. This is one of the annoyances, is that ARKit, its vector types are not the same as SceneKit vector types. So it's a bit of an annoyance, but you can write a small extension that you can use to convert among these types. So let's go over this function. Let's start from here. So I create a cat, this cat node. I add it to the scene. Now I want to position it. So what's the starting position of our missile? It's where the phone is. You can get that from sessions, current frame, camera. So there is a camera object that represents the camera on the phone. it has a transform, which is basically a matrix that holds its position and orientation. Turns out, position is third column of that matrix. All right, assign that to the missile. Now, I want the missile to move. To do that, you can apply some force to its physics body. The force that we want to apply, you have to give it a vector, because it determines direction and the magnitude, or how fast the cat will go. Turns out, second column is a forward vector which points to the user. So you have to multiply it by -1, which I do here. And I also actually multiply it by -3, so the force is like stronger force. The cat will fly faster. The last line just removes the missile after 5 seconds from the scene. All right. Now, before I run this, I'll do 2 more things. I'll disable the gravity by setting it to a 0 vector, and I'll assign a contact delegate. So it's an object that can get informed when 2 things collide. So you have to conform to this protocol or an interface, and then you can override method. How was it? Contact delegate implementation. So this method gets called when there is a collision in the scene. What I do is take both objects that are participating in a collision and remove them. To make this more fun, let's add some sounds. And then our game will be done. So I have this function that plays audio. I have 3 files in my project. When things collide, I'll play hit. And when we touch the screen, I'll play like a shoot. And it's a pickle. It's a very annoying pickle, so it has to scream. All right, let's hope I didn't miss anything. All right, here are the pickles. Let's try tapping the screen. Oops. Thank you. Okay, this one. Yeah. That's our game. It's a 10-minute game, but I'm sorry. So it's really, my whole point of showing you this and making this is to show you how it's really easy to make AR stuff with ARKit and SceneKit. Just a couple of lines of code, and you can have a simple game or something. And that's actually it. That's what I have for you today. If you have any questions, you can ask them, or you can also ask them later, because I'll be downstairs at the shapes space, the big red logo, you'll see it.